Hello everyone, in this video I'm going to be explaining the limit comparison test, and then I'm going to provide you guys with two examples using the limit comparison test. So the limit comparison test states that if the limit as n approaches infinite of a sub n divided by b sub n is finite and non-zero, then the infinite series a sub n and b sub n both converge or both diverge. Now I'm going to solve one of the examples. Example number 1. It says, in example number 1, we have the infinite series of 1 divided by 2 times n plus 1. We're going to use the limit comparison test, and if we take the limit as n approaches infinite of a sub n, which is just 1 divided by 2 times n plus 1. And I should mention that b sub n is like basically the simplified version of a sub n. So like here, our b sub n would be equal to 1 divided by n. We have to take the limit as n approaches infinite of a sub n, which is equal to 1 divided by 2n plus 1. Divided by b sub n, and so we're going to divide this by 1 over n, which is the same thing as multiplying this by n. If we take this limit, then we'll get 1 divided by 2, which is both finite and non-zero, which means that the infinite series a sub n and b sub n either diverge or converge. Let's look at the infinite series 1 divided by n, which is b sub n. This is the harmonic series, and this series diverges. Since one of the series diverges, that means the other series also diverges, since they either have to both converge or both diverge. So using this, we know that the infinite series 1 divided by 2 times n plus 1 also diverges. Now I'm going to solve example number 2. We have the infinite series 1 divided by 3 to the power of n plus 5, and if we use the limit comparison test, then we would have the limit as n approaches infinite of, this would be a sub n, and b sub n is the simplified version of a sub n. So our b sub n would be equal to 1 divided by 3 to the power of n. We have to take the limit as n approaches infinite of n sub n, which is equal to 1 divided by 3 to the power of n plus 5, and divide this by b sub n, which is equal to 1 divided by 3 to the power of n. If we divide this by b sub n, then that's the same thing as multiplying 3 to the power of n. If we take this limit, then we'll get 1, which is both finite and non-zero. So we know that the infinite series a sub n and b sub n both either converge or diverge. Let's take let's look at the infinite series. Let's look at the infinite series 1 divided by 3 to the power of n. Well, this is equal to 1 divided by 3 all to the power of n. And remember, this is geometric series. R is equal to 1 divided by 3 in this case. When in the geometric series, when R is smaller than 1, then that means that the infinite series converges. So that means that this infinite series converges. Since they either both have to be converge or diverge, and we know that one of them converges, of course. So then, of course, the other infinite series, which is the infinite series 1 divided by 3 to the power of n plus 5, this also converges. So I think that's it for this video. And I want to thank you everyone for watching this video, and I hope I will see you everyone in the next video. Bye.